Okay, in this video I want to talk about finding the sum of a finite arithmetic series. So remember, an arithmetic sequence is just a sequence, it's just a listing of numbers where to go from one number to another number, there's a constant difference. So notice in my listing of numbers I've just made here, 5 to 11 to 17 to 23, you're adding 6 every time to get to the next number. And that's an example of what we call an arithmetic sequence. When we start actually adding those numbers together, that's when we talk about what's called an arithmetic series. Okay, so series has something to do with adding the terms up. And the formula says, it says the sum S sub n of the first n terms of an arithmetic series, looks like A sub n, of an arithmetic series. This is the formula for A sub n. It's A sub 1, which represents the first term of the sequence of the series, plus n minus 1 times d. And here are two equivalent formulas for the sum of those n terms. We take the number of terms n, we multiply that by the first term plus the last term, and then we divide that by 2. Or equivalently, we can take the number of terms, then we have in brackets 2 times the first term plus n minus 1 times d. d again is the common difference. So here my common difference, we would say our d value is 6, because that's what I'm adding by to get to the next term. And then again we divide that by 2. So I'm going to do two kind of quick problems here. And so I've put my formulas here at the top. So suppose we start looking at this arithmetic sequence. 2, 5, 8, 11, 14, 17. Notice this is arithmetic because we're adding 3, 3, 3, 3, 3 each time. So our common difference is a d value of 3. And I'm going to do two things. I'm going to find the sum of the first 10 terms, and then I'm going to find the sum of the series starting with the 11th term but ending with the 28th. So kind of some stuff in the middle I'm going to add up. Okay, so I can use either one of these formulas. I think I'm going to use the one here on the right when I do part A here. So let me erase part B here. Actually, I want to point out a couple things here too, but we'll do that first. Okay. So we're adding A1 plus A2 plus A3 up to A10. We know what A1 is. It's 2, A2 is 5, A3 is 8. We've got a formula to calculate A sub 10 if we wanted to, and then we could just plug that in, or equivalently, again, I'm just going to use this formula. One remark I want to make here, how many terms are we adding up? Well, we're certainly adding up 10 terms, but this is going to kind of play into the second problem, is why I'm pointing it out. If you start with the first term and you end with the 10th term, notice if you subtract the indexes 10 minus 1, you get 9, but we do have 10 terms here, so keep that in mind because I'm going to revisit that in the second example, that idea, because I think people do make some mistakes. But okay, so I think this one's pretty straightforward. So to use this formula on the right, it says we take the number of terms, which we just said is 10. It says we take 2 times the first term. Well, the first term in this case is 2. We take the number of terms and subtract 1, multiply that by d, again the common difference, which in this case is 3, and then we simply divide all that by 2. So just be a little careful with your order of operations. Let's see, 2 times 2 is 4 inside, 10 minus 1 is 9 times 3, that's going to be 27, all divided by 2. Well, 10 divided by 2 is 5, 27 and 4 is going to give us 31, and it says if we were to add up all those numbers and to list them all out, we would get the sum 155. Okay, so not too bad. You can certainly use this other formula. You can compute A sub n using the formula I had on the kind of the first page, and then show that you do get the same thing, or write them all out and add up the first 10 terms and see that you get it. So let's do the second part of my problem here. And there's many different ways that you could use the second part of this problem. So I'm going to keep in mind, we said you got 155 for part A. Part B, we wanted to add the 11th term. So starting with the 11th term through, I think I said the 28th term. Okay, so again, I'm going to use the same formula here on the right, but we just have to be a little bit more careful about what we plug in here. Okay, so the 11th term, that's going to be a sub 11, that's what we'll start with, and then we would add the 12th term, the 13th term, all the way up to the 28th term. So in this case, n represents in this formula the number of terms that you're adding up. So the number of terms in this case, this is where you have to be careful. This is what I was saying a second ago. You can't just take 28 minus 11. That's not correct. It's going to be one too few. And remember, if we did A1 through A10, we said if you add that up, well, if you count them, you certainly get 10, but if you subtract, you get 10 minus 1, which is 9. So the idea is to get the number of terms, you can subtract the indexes, but then you have to add 1. So I'm going to add 1 to this to get the correct number of terms. So 28 minus 11 is 17 plus 1. It says we have 18 terms that we're going to add up. And I'm just simply going to compute the first number, and I'm going to plug it in right here. Again, it's not a sub 1 of the original series, but it would be the first term of my new series. So that's the idea. Okay, so we said a sub n is going to be our first term. So to calculate the 11th term, we do have to go back to the original. So a little confusing here. You really have to think about where things are coming from. So a sub 11, it says we take the first term, which is 2. We take n minus 1, which is going to be 10, times the common difference, which in this case is 3. So you get 30 plus 2, or 32. So that's actually going to be, I should put a sub 11 down here, excuse me. If we were to list all the terms out in this this original sequence, you would find that when you get to the 11th term, that's when I get the number 32. Okay, so now I'm just going to use this original formula again because I think I have the crucial information. So we said there's going to be 18 terms. So again, this one's certainly a little bit trickier than the first one. The first one's pretty straightforward. So 18 terms, so it says it says the sum of those terms, it says it's going to be n, which is 18. We take 2 times the first term, which would be 32. We take n minus 1, which would be 18 minus 1, or 17, times the original d value, which is 3. And then again, we have to divide all that by 2. Alright, so 18 divided by 2 is 9. 2 times 32, that's 64. 3 times 17, what is that? That's 51. So 64 and 51, what is that? Looks like 115. Oh, 9 times 115. What's that going to be? You can check my arithmetic. I think it's going to be 1045. Should be. No. How about 1035? That sounds better. Yes, much better. Alright, so again, the second problem's a little trickier because you're kind of adding things starting in the middle. So we really have to figure out what the first term would be, which in this case would be figuring out the 11th term. And that's what we did, and then we were just careful to count the number of terms, and then we just used our formula. So part B might be a little trickier. You might have to watch it a couple times. And of course, as always, you should really stop and think it through yourself before you do anything. So there's certainly, I think, other ways to do it. That's simply one way of doing it. So, alright, I hope this example makes some sense and helps you out. If you have any questions or comments, feel free to post them. Hopefully me or somebody else can point you in the right direction.